Hi everybody, Patrick here from Engineering Shock Electronics, engineeringshock.com. This is the getting started video for the ES6937 motion sensing swivel disc. And if you haven't already checked out the Kickstarter campaign, check it out below. This swivel disc is an awesome mount that can allow for you to detect humans and animals as they enter a room. And we're going to go through three main code samples. This is the first one, and we're going to basically what we're going to do is we're going to break this down into three steps. First, we're just going to be able to sample the output and view it, and that's what this program is for. In the second program, what we'll do is we will filter out the power-up sequence where the sensor becomes unstable. We're going to filter that out and only allow the program to sample after the sensor has become stable. And in the third video, with the third code sample, what we're going to do is we're going to create a window comparator that basically allows for us to control the sensitivity to trigger an action. That one is coming up. Both of those are coming up. I'm going to be working on those today. But each of these code samples are fully commented and they build off each other. So the next piece of code will include most of this and it will build on it. And then the final piece of code will build on that. So the idea is you can learn as we go. Everything, as you can see, fully commented. And that goes for all pieces of code. And when the campaign is done, that will be up at engineeringshock.com. So if you haven't already, check out the Kickstarter. It's a fun one and it's not overly expensive by any means. Anyway, so I'm going to go to the Tools bar. And you're going to go down to the serial plotter. And this will cause a reset. Oh, because it was already open, it did not cause a reset, but I want it to reset because I want to show you what happens when you power this up, when I power this thing up. So I reset it. And as you can see, we're sitting at around 0 volts. And there's a huge swing. Keep in mind that the left side of the screen is the scale, and the scale keeps changing based on the signal. So because this was recently powered up, it didn't take very long for it to become stable. And we're now sitting at between 395 to 408. Now, what we're going to be reading is likely between 0 and 800. Now, the full scale voltage of this ADC, the analog to digital converter, is 0, which is 0 volts, and 1023, which is 5 volts. But the output of this sensor is going to saturate at around 800, which is about just over 3 volts and 0 volts. So if I unplug completely and let the sensor power down, what are those legs of this? I'll power back up now, just so you can see a proper opening to this, where the sensor becomes unstable. Sensor needs some time to become stable, so that's not stable. That's between that one from 0 to 800, where it's going to saturate, and it's slowly going to go back down after a minute or two. There we go. Now it's starting to stabilize at around 400. That's what we expect to see at around 400. So now it's between 384 and 400. So this is ideal. This is ideal. This is, as you can see, the scale has changed, and we're now stable at in and around 400. My cat's in the background, so he might be causing a bit of a swing, but we're talking these are tiny swings because the scale is so small. So if I place my hand in front of the sensor and I move it back, as you can see, that went from 400 to 750 and then down to 300 and then stabilized back at around 400 after my hand left the view. So I'll do it again. I'll do it 3 times. 1, 2, 3. It's very sensitive. So let's look at the code. We have to use 3 analog pins for the disc. We're going to use analog pin 3 as our ground. Analog pin 1 is our 5-volt power supply, and our analog pin 2 is our motion sensing input from the disc. Now, why are we using analog pins for ground and power supply? Because we can. If we set AD3, analog pin 3, as an output and set that output low, it's the same as a ground. And we're going to set AD1 to 5 volts. We're going to set it high. We're going to set it as an output. We're going to set it high, which means that it'll provide 5 volts to the disc. And because the disc requires next to no power, we can do this no problem. And of course, AD2 is our input, which samples the voltage on the disc. So in the void setup, we're going to use the command serial begin 9600, and that will allow for us to use our serial plotter. We're going to declare pins A3 and A1s as outputs because we don't want to use them as analog inputs. Then we're going to set A3 to low to create our ground, and we're going to set A1 to high so we can create our power supply, and we'll wait 1 second. In the void loop, we do something very simple.
We use an integer hold, and we take an analog read of pin 2, and we place the result in hold. And of course, this value will be between 0 and 1023, but more likely 0 to 800 because the sensor saturates. Then we print ln hold, the value that we just sampled, and then we wait 10 seconds. And we do that over and over and over again. And that's all we need to do is to open the serial plotter and see this. This is what it's doing. It's taking a sample every 10 milliseconds. And so, yeah, very, very simple code. Now, the next piece of code will build off of this, and the code sample after that will build from that. We're going to take steps. Now, one last thing is, as you can see, we're fully commented here. Every single piece of code will be fully commented, and I've tried to make everything as simple as possible. It's quite simple, but for anything that's a little bit ambiguous to you as we move along, the comments are there, and I've spared no time. I've done my best to comment these to the best of my ability. So if you haven't already, check out the Kickstarter link below. I'd certainly appreciate it. But even if you didn't, thanks for watching. I hope you have a wonderful day. Thanks for your time, everyone. Take care.